Antarctica is the most extraordinary continent on Earth, vast beyond imagination. Covering over 14 million square kilometers, it is larger than all of Europe and ranks as the fifth largest continent. If you were to cut Antarctica out of the map and place it over North America, it would nearly stretch from Canada to Mexico. This frozen giant is over 98% covered in ice, making it a true kingdom of snow and ice. But Antarctica is not just enormous, it is also exceptionally harsh. It holds the title for being the coldest, driest, and windiest place on Earth. Winter temperatures can easily drop below -80 degrees Celsius, and even in summer, they hover around -30 degrees Celsius. Winds often exceed 200 kilometers per hour, strong enough to knock a person off their feet. Combined with the extremely dry air, most of Antarctica resembles a natural frozen desert. In many parts of the continent, it hardly ever rains, with only a light dusting of snowflakes throughout the year. This environment makes Antarctica one of the most inhospitable places for life on the planet. The extreme climate conditions mean that Antarctica is almost entirely devoid of permanent human habitation. Even in summer, the population is limited to about 4,000 scientists and staff stationed at various research outposts. During the long, brutal winter, this number plummets to around 1,000 as most personnel leave, leaving behind only a dedicated few. This stark contrast between its high season and low season adds to the continent's air of mystery and solitude. When we think of Antarctica, the image of endless ice fields and biting winds might come to mind. But did you know that beneath this frigid, white expanse lies a hidden geological wonder, a kind of underground world? Among its most fascinating secrets is Lake Vostok. Buried beneath 4 kilometers of ice, along with other enigmatic subglacial lakes and volcanic heat caves. How was Lake Vostok discovered? In 1964, Andrei Petrovich Kapitsa conducted seismic studies in the region of the Vostok Station. By analyzing seismic data, airborne radar profiles, and surface elevation measurements of the ice, he uncovered the existence of this lake. Surprisingly, the water in the lake is relatively warm, between 10 degrees Celsius and 18 degrees Celsius, suggesting the presence of geothermal heat sources. Lake Vostok is the largest subglacial body of water in Antarctica, entirely isolated from sunlight, winds, and surface life. It is estimated to have been cut off from the outside world for about 14 million years. Above the lake, there is a dome several hundred meters high, filled with air, adding another layer of mystery to this hidden world. Lake Vostok, a massive subglacial lake, has been isolated from the rest of the world for millions of years, earning it the nickname the Amazon beneath the Antarctic ice. Its area is comparable to North America's Lake Ontario, yet its waters have likely never interacted with the external environment, harboring a completely independent ecosystem. When scientists analyzed water samples from the lake, they discovered DNA from thousands of microorganisms, many of which were previously unknown. These mysterious life forms may offer insights into how life survives in extreme environments and even provide clues for the search for extraterrestrial life. The intrigue doesn't end with Lake Vostok. Beneath Antarctica's thick ice sheet lies a network of hundreds of similar subglacial lakes connected by intricate waterways, forming a hidden underground river system. These lakes are warmed by geothermal heat, creating isolated sanctuaries that could support life. Such subglacial aquatic ecosystems are believed to be unique on Earth, offering an unparalleled glimpse into life in extreme conditions. Antarctica also boasts geothermal caves in its Little Antarctica region, shaped by volcanic activity. These warm refuges are another haven for life. In the caves around Mount Erebus, scientists have found algae, mosses, and even tiny arthropods. Temperatures inside can reach up to 25 degrees Celsius, a stark contrast to the frigid conditions outside. Researchers speculate that life forms in these geothermal caves may have evolved unique adaptations, with some potentially representing species yet to be discovered. The mere existence of such resilient life is astounding. These organisms survive in dark, isolated, high-pressure environments, relying solely on limited energy sources like geothermal heat or minerals. Their diversity and tenacity not only deepen our understanding of Earth's life, but also fuel hope for discovering life in similar environments beyond our planet. If life can endure the harsh conditions of Antarctica, could it also exist on Jupiter's moon Europa or Saturn's moon Enceladus? Antarctica's subglacial ecosystems are directly tied to the search for extraterrestrial life. Europa and Enceladus, for example, have ice-covered surfaces with potential liquid water beneath. Life forms in Antarctica's subglacial lakes act as a natural laboratory, allowing scientists to simulate and study extreme conditions that may mirror those on other planets. In this sense, Antarctica is not just part of Earth, but a bridge to unraveling the mysteries of life in the cosmos. Antarctica's ice sheet, holding approximately 61% of the planet's fresh water, is a colossal treasure chest of water. Its average thickness is an astounding 2 kilometers, with the thickest parts reaching nearly 5 kilometers, equivalent to stacking 6 Burj Khalifas. This massive ice sheet plays a critical role in global climate and sea levels, making its stability far from trivial. What would happen if Antarctica's ice sheet melted completely? Scientists estimate that such an event would raise global sea levels by an astonishing 60 meters. Imagine this: current coastlines would be completely redrawn, major cities like New York, Shanghai, and London would be submerged, and vast areas of land would vanish beneath the waves. The consequences would impact hundreds of millions of people, devastate ecosystems, and disrupt global economies. Although the ice sheet's melting is not yet at a catastrophic rate, climate change is making the situation increasingly precarious. Every piece of melting ice contributes not only to rising sea levels, but also to altering Earth's climate systems. For instance, melting ice releases large amounts of fresh water, which can disrupt ocean circulation, the regulator of global climate. If this regulator falters, the result could be more frequent extreme weather events, such as stronger hurricanes, severe droughts, and widespread climate anomalies. Antarctica stands as a reminder of Earth's fragility and the interconnectedness of its systems. Its study not only deepens our understanding of our planet, but also opens a window to the universe, inspiring the quest for life in the most unlikely places. Beneath Antarctica's icy expanse lies a dramatic chapter of Earth's history, a meteorite impact that may have altered the planet's fate. In East Antarctica, scientists have discovered a massive impact crater, which some believe could be the culprit behind the Permian-Triassic extinction event. This crater is remarkable. Through gravity, anomalies, and geological analysis, researchers identified an area beneath the ice that matches the characteristics of a classic impact structure. The scale is immense, with an estimated diameter stretching hundreds of kilometers. Imagine a 50 kilometer wide asteroid slamming into Earth at unimaginable speed. The energy unleashed would trigger a global catastrophe. Scientists estimate that this impact occurred around 250 million years ago, coinciding with the largest mass extinction in Earth's history. Over 80% of marine species and 70% of terrestrial vertebrates vanished in a geological blink, reshaping the course of evolution. What changes did this impact unleash? First, there would have been immediate devastation, massive earthquakes and tsunamis dwarfing today's natural disasters. Volcanic activity may have been triggered, spewing ash and gases into the atmosphere, blocking sunlight, and causing a global cooling effect. These chain reactions likely persisted for thousands of years, transforming Earth from a warm, humid environment into a harsher world. Ancient climate data from Antarctica supports this theory, suggesting that the continent underwent a dramatic shift from green landscapes to a frozen wasteland. Yet this catastrophe may have also paved the way for new beginnings. The Permian-Triassic extinction cleared ecological niches, creating space for dinosaurs to dominate and eventually for mammals to rise. Without this event, dinosaurs might never have ruled, and mammals might not have had their evolutionary stage. Antarctica, as a silent witness to this impact, may hold crucial evidence in its ice and rock layers, waiting to be uncovered. Scientists are delving deeper into this ancient impact site. Through drilling and radar surveys, they hope to find direct evidence such as melted rock or meteorite fragments. These discoveries could not only confirm the impact, but also reveal its precise effects on Earth's environment. Antarctica's frozen expanse also conceals vast untapped resources, enough to make any economist's heart race. Beneath the ice, there may be immense reserves of oil, natural gas, and rare earth elements, resources that fuel modern technology and global economies. Estimates suggest that Antarctica could hold up to 500 billion barrels of oil and gas, potentially making it one of the largest undeveloped energy reserves on the planet. Yet these resources remain untouched thanks to the Antarctic Treaty, which mandates that the continent be used only for peaceful purposes and scientific research. Commercial exploitation is strictly prohibited, keeping these treasures safely asleep under the ice for now. However, the treaty isn't permanent. In 2048, it will reach a pivotal review point, allowing signatory nations to renegotiate its terms. If resource-hungry nations argue for development to meet domestic demands, Antarctica could become a hotbed of contention. Intense international negotiations, economic interests, and environmental debates are likely, with major players like China and the United States poised for confrontation. Antarctica's rare earth elements, REEs, are another focal point. These elements are essential for modern technologies, from smartphones and electric vehicle batteries to jet engines, laser weapons, and missile guidance systems. Currently, global REE supply is heavily concentrated in a few countries, making extraction challenging and expensive, especially in Antarctica's harsh environment. China, holding over 37% of the world's known rare earth reserves, leads global production and refining, contributing about 70% of the world's output. Its advanced technology and dominance in the REE supply chain make it a key player in this field. Despite this, the uneven distribution of rare earth resources drives global interest in Antarctica's potential deposits. Antarctica stands at the crossroads of scientific discovery, resource potential, and environmental preservation. As the world's frozen reservoir and a symbol of international cooperation, its future will depend on a delicate balance between exploration, sustainability, and the geopolitical ambitions of nations. Antarctica is more than just a frozen continent. It serves as Earth's time capsule, holding secrets about past climates and ecosystems. These secrets could be the key to understanding the trajectory of future climate change. Imagine each layer of ice as a page in Earth's historical diary, recording everything from atmospheric compositions millions of years ago to traces of ancient ecosystems. By analyzing ice core samples, scientists can reconstruct the Earth's past, offering insights into how climates have shifted naturally over millennia and how human activities have rapidly caused profound impacts. One extraordinary feature of the Antarctic ice sheet is the tiny air bubbles trapped within. These bubbles encapsulate the atmosphere of their time, allowing us to breathe the air of Earth as it was millions of years ago. By studying these bubbles, scientists can precisely trace changes in greenhouse gas concentrations, such as carbon dioxide and methane, and link them to historical climate events. For instance, what ended the ice ages? What triggered past warming periods? The answers to these questions may lie buried in Antarctica's icy layers, but the significance of the ice sheet goes beyond understanding the past. By studying these ancient clues, we can better predict the future. For example, examining the rate and patterns of Antarctic glacier melt helps us forecast the extent of future sea level rise. This research provides critical data for planning and adaptation in coastal cities worldwide and serves as a foundation for global climate policy. Against this backdrop, the balance between preservation and development becomes especially important. Antarctica is not only a frontier for scientific exploration, but also a litmus test for global environmental governance. If we can find a sustainable way to manage Antarctica, it could serve as a model for other regions. However, if resource competition leads to conflict or environmental degradation, the consequences will be felt across the globe. Scientists are working to better understand the dynamics of Antarctic glaciers, essentially how these massive ice formations move and melt. Though glaciers may appear stationary, they are constantly in motion, slowly sliding, cracking, and sometimes calving into the ocean. These processes can be awe-inspiring, like the dramatic detachment of a colossal iceberg drifting into the sea, yet they are also alarming as they indicate accelerating ice loss. Using advanced tools such as satellites and ice drilling technology, researchers aim to predict changes in the ice sheet and devise strategies to mitigate global impacts. Still, we are not powerless. Scientific research not only helps us grasp what is happening, but also provides vital data for action. By reducing greenhouse gas emissions and protecting polar ecosystems, we can slow these changes and work toward a more stable future for our planet. The shifting ice of Antarctica is a clear signal that climate change is here, and its effects are spreading to every corner of the globe in startling ways. This white continent is disappearing, and its story is a story for all of humanity. We must heed its warning and take action before it is too late.